Hello, everybody. Hello. I hope you hear me. I don't hear myself very well, so I hope you can hear me better than I hear myself. Welcome at our session, The New Battlefield, Space Defense and the Future of Military Operations. My name is Teresa Pulterova, and I will be your moderator for the next 60 minutes. Now, space has been an integral part of space operations ever since the first satellites were launched to space in the 1950s and 1960s. But we've certainly been hearing quite a bit more about space in recent years. We've been hearing about the risk of a nuclear detonation in space. We've been watching the war in Ukraine unfold through the eyes of Earth observation satellites. Since 2019, the US has its dedicated Space Force. So there's been a lot going on in space in recent years, and our four guests are here to help us make a better sense of what it all means for the defense forces. So my first guest is Ben Greene, who is the founder of defense technology company EOS. Hello. Next we have Juliana Suess, who is a research fellow and space security policy lead at the Royal United Services Institute, which is the world's oldest defense and security think tank. Welcome. Next, we have Pierre-Emmanuel Haensler, head of research at the Surveillance Systems for Aerospace and Defense Unit at ONERA. Thank you for being here today.
Thank you.
And next, we have Rory Welch, Vice President for Global Government and Satellite Services at satellite communications provider Intelsat. Thank you for joining us today.
Thank you, Teresa. Glad to be here.
I hope you hear us, because I don't think he hears us very well. So I just want to say, if you have any questions, there will be time for you to ask them at the end of this session. So whatever comes to your mind while we talk, just remember it, and there will be space for you to ask your questions. So let's get started. We don't have that much time. Let's start with a little bit of context. So how much has the importance of space for the defense and military operations grown in recent years? Who wants to start?
Thank you for the introduction. To understand, we have to go back to 1950, when the air domain was considered the dominant...
Your microphone closer.
Too close?
Your microphone closer.
We have to go back to the 1950s, when the air domain was considered the dominant domain of warfare over all surface warfare, which included naval warfare and land operations. And somewhere around 1975-80, this transitioned such that the space domain became the dominant domain of warfare. So what that means is if you control the dominant domain and you have escalation of dominance in that domain, you can control warfare in all the other domains. And we see that evolve over the last 40, 50 years to where now space and cyber are relatively universally regarded as the two dominant warfare domains today. And we're here to talk about space.
Yeah, I can only agree. I mean, the vast majority of military operations could not take place the way that they currently do without space. And obviously all this started a little while ago. You know, you remember the first use of GPS in the 90s, but we've come a long way in the last 30 years as well. So increasing amounts of data, intelligence, surveillance, reconnaissance is all sort of sent down from space. But also satellite communications, right? Beyond line satellite communications. All of that is taking place through space. So, you know, space is often seen as a sort of luxury add-on by militaries, but it's not an add-on. It's your baseline.
Yes. So, for my part, I come from the space surveillance domain. So, what I can say is that knowing what are the assets in space is crucial, is very important in order to know who's operating, but also who is actually able to impeach what you are doing on the ground. So there is a very deep bond between what's going on in the space and what's going on the ground. And it's been like that for a long time, and it's just accelerating in the recent years. But it's always been the case. Yes.
I guess I'll just add on that, as others have said, space is becoming increasingly important to modern warfare over the decades, and I think its importance and the applications have evolved as the concepts of operations and technologies have been evolving in the other domains. And so today, you see the importance of, say, precision navigation and timing. That's ubiquitous across the force. remote sensing for awareness of what's happening and making decisions, and even things like weather predictions to manage operations. And then what my company is really around communications, because many of the modern military operations are very distributed over large swaths of territory, could be spanning the globe. So you need to be able to communicate and share information and make decisions, and I think that's just reflecting how important space has become over the decades.
Thank you. So there's a lot of innovation going on in the space sector. For example, we know that the Starlink constellation, which is quite a new thing, has played quite a big role in the conflict in Ukraine. But in your perspective, which innovations that we are seeing, coming or that are sort of happening will play a big role in the defense sector in your view?
All right, so I'll start this time. So I'd say first off, when it comes to space, what you're seeing, I think what's been very important in the recent history is the proliferation of space capabilities across multiple orbital regimes. And so certainly Starlink has been a big player in the LEO regime, but that's reflecting that communications historically was done at GEO and it's been migrating to other domains, other orbits. I think you're seeing the same thing where there's more functions that it may have been in very narrowly focused capabilities are now being distributed, and you're seeing a lot more, but you're also seeing a lot more threats to space, and very, very robust RF interference, cyber interference, even counter space weapons and things like that are having to be dealt with. So it's many different things, but I think it's really the fact that you're seeing these capabilities being proliferated across many different platforms, many different orbits.
If I were to talk about one technology, I would stress out in-orbit servicing. Most of the activities in space are mainly dual, because there is a huge part of civil activities, but it's also always linked to defense activities. And so there is a huge problem of debris. Also, the population in low orbit, especially, is dramatically increasing. With a lot of uncertainties about what it's going to lead to in the next 10 years. And so there is a major trends. First, there is the fact that there is a need for active debris removal, and there is also the fact that the same technologies can be used for in-orbit servicing to extend the life of satellites or to provide repairs, maintenance, etc. And it's basically a tool that can be used any way you want to use it. So of course it's completely defense related. So for me that's a technology that's meant to evolve very quickly and to become very common. And so the capabilities linked to that technology are going to be evenly distributed all over every company, every defense agency, and so it's going to be a tool that can be very threatening if broadly used in a way to conduct defense activities.
I think Rory's already alluded to it in the sense of the sort of proliferation of threats we're seeing in space. So I would actually say that it's the sort of resilient aspects in space that are going to play a large role in the coming years, specifically inter-satellite links, which specifically give satellite communications an extra layer of security in the sense of satellites can sort of relay messages to each other and therefore circumvent or potentially compromise ground station, for example.
So I'll take Rory's point in a slightly different way. I think the single largest impact has been the real cost per kilogram of launch to any altitude you want to name is down by a factor of 100 over the last 25 years in real terms. This means this speaks to proliferation, but it speaks much more to capability, intent, ability to implement intent, and the accessibility of space capability to many countries. And I think close on behind that and connected to it is the second largest impact I see is interference in space. Making war in space has much more implications today on our economies and our ability to function as economic units, national economic units than ever before. If we go back 30, 40 years, and that's not even as long as I've been in the space warfare business. We could talk about taking down LEO satellites with impunity. There were no implications. These days, the debris field would take out 10, 20, 100 satellites within 5 days. So the implications have gone up at the same time that there are many, many new participants in space that don't have a heritage of responsible behaviour. So I think the volatility of the environment has increased dramatically.
What about technologies that are a bit further down the line, like upcoming things? Is there something you foresee could be like a game changer in the future? And how do you expect, let's say, the integration between space and defense to sort of evolve?
So in terms of new technologies that will be game changers, I think if we go back again, I see things in a historical context, perhaps because I've seen how this strategically and tactically evolves over decades. The ability to interfere in space has increased dramatically. There are new technologies, both in terms of mission degradation, right through to satellite kill. And in the old days, these were clumsy kinetic kill vehicles that had to go through a whole range of proximity operations to be able to achieve their objectives. These days, there are many, many more ways of negating space assets.
I would also add something that Pierre said earlier about sort of in-orbit servicing, refueling, maintenance, and it's exactly that sort of push and pull between sustainability and security in the sense of it's obviously good if we can keep space as sustainable as possible. We are able to refuel, increase the lifetime of satellites and sort of use them for longer, reduce their space debris as a result. On the other hand, people are getting increasingly worried that if you can get close to a satellite and either grab it and pull it out of the way or refuel it, that could also lead to nefarious activity. Right? So I think we're going to see that push and pull more and more. But also talking about the integration element, I said earlier we're going to see even more data coming from space, even more sensors coming from space. And the problem that we are going to see soon, or that we're already seeing, is actually not in space, it's the ground element. And how are we actually going to sort of integrate the sort of masses of data that are coming our way and process it effectively and quickly enough to actually act in a tactically relevant manner? I think that's what's sort of going to become an issue sort of much quicker rather than anything in space.
So we could be talking about technologies in space to use for what's happening on the ground, or technologies in space for acting in space. And if I'm focusing on just the space domain, I would say that reactive launch seems to be something that's going to be very important, because when you are surveilling what's going on, there is a task of general surveillance. Then you have to detect, identify, characterize what the targets are doing or intending to do, and then you have a very little time to react if there is a need to react. So today it's going to be based on ground-based systems or what you already have in orbit, but it's especially complicated to anticipate for the future needs. So the time to go from ground to orbit is a major constraint in this whole chain of reaction. And reactive launch is a technology that's developing and is going to be a major asset in the future to be able to adapt to any new threat that you have just detected and you need to react to.
So to add on to maybe what Juliana was saying, certainly modern warfare continues to evolve where data is, and the data needs are continuing to just grow exponentially, and to be able to transport that data, process the data, but get it ultimately to the people that are making decisions, and then to the people at the pointy end of the spear who can actually influence the activities is going to be increasingly important. And at the same time, the threat is evolving to disrupt that, because you're trying to operate a network where you can be whether it's a terrestrial network, network in the sky, network in space, and and many different layers and different nodes in the network. So the space network of the future has to be much more resilient and robust in the face of those threats, and also be much more capable and interoperable to allow military systems to operate with commercial systems. Because you're seeing, I mean, if Ukraine's pointing at nothing, it's the growing importance of commercial space. And so in the future, those military and commercial networks need to be able to operate together more efficiently. And so I think where you see the technology changes that are going to drive things is the development of standards that allow those different networks to talk to each other and across layers, whether it's different orbits in space or between space and terrestrial layers. So that's one, is to get to standards. Because I always use the example, everyone has a cell phone today. It wasn't too many years ago where your phone operated only on its own network and you had to pay some exorbitant roaming charge or have special cards to be able to make it work. Well, in the future, you're going to want to be able to have your space device or your sensor, your node of the network operate across many different networks somewhat seamlessly. So that's one thing, is around standards and virtualization to make sure the network can operate much more automatically. And then you're going to be having from a communications perspective, you're going to have satellites that are more capable, multiple orbits, be able to talk to each other. And then also on the ground, you're going to have the users are going to need to have terminals that are smart and be able to operate across networks and be easy to use and give them connectivity to multiple networks. I could go on and on, but I think those are probably some of the high points.
Thank you. Let's have a look at adversary technologies. We know that China, for example, is investing quite heavily into space. So based on what we know about China's drive in space, are there any kind of gaps or areas where the Western world should focus more? Any areas of concern that you would like to point out?
I think what I'm worried about the most, and you mentioned China, I think it's interesting if we consider China and Russia in space, because actually China's been investing very consistently in space and space capabilities. China has a lot to lose in space. And we've seen, obviously, I don't know if the audience knows, there's a couple of sort of counter-space capabilities. I'm sure we'll come to talk about them later on in the panel as well. But China did one particularly big anti-satellite weapons test in 2007, which caused a massive debris. Obviously, it was called out by the international community pretty quickly. And since then, China's reliance on space is growing massively, but also they haven't really used these sort of incredibly destructive tests since then. Russia, on the other hand, whose sort of space power status has been declining quite rapidly, we've seen them sort of use this technology much more, and actually they did carry out very destructive anti-satellite tests in 2021, which caused also massive debris, but also specifically caused a massive debris in low Earth orbit, which is where the ISS is stationed, thereby immediately also putting at risk Russian citizens who were aboard the ISS. So you already mentioned responsible behaviours, the sort of legacy of responsible behaviours. Russia has not been behaving responsibly in space. I would argue neither has China, but one actor has more to lose than the other. In terms of sort of obvious gaps that there are, don't get me wrong, the US is still the preeminent space power, right? I think that's sort of uncontested at the moment. I think do keep in mind China's catching up. As I said, very consistently sort of investing in space, and they do have the goal to be the leading space power by 2045, or at least among the leading space powers. So that's definitely something I would argue gaps are in the resilience.
That's right. Sorry about this, unplanned.
Maybe that was my cue because I was talking for too long. But I would argue, and I've said it before in my earlier answer, but I think resilience is the thing to invest in the future. We talked about proliferation of orbits, proliferation of actors. I think there is actually the sort of strength that the Western world has over actors like Russia and China is the commercial sector and the private sector and the innovation that comes from that. rather than focusing on just sort of state programs and state projects.
Anybody else has anything to say on this?
I guess my view would be that the generation of large amounts of new space debris is not necessarily irresponsible in the nationalistic sense, or even accidental. I mean, as a space intelligence officer, I can go back to when it was relatively easy to hide 10 or 20 space vehicles in a debris field of 20,000. These days, it's much more the state of the art to hide 500 space vehicles in a space debris field of 100,000. And so the capability gap, I think that goes to your question, that we look at first, and what we focused on in Australia has been to build sensors that can readily, easily and affordably track 100,000 space objects in real time with great accuracy, detecting velocity changes at the millimetre per second rate, so that space debris and space vehicles can be easily differentiated in terms of how they fly. So there are many ways to address the capability gap. I agree that for now, the US and the Western powers still have the most to lose in the loss of access to space. But that asymmetry is changing very quickly. And I think that we will see more debris fields enhanced with greater populations of debris as this game continues, because hiding the assets in the debris field, every time we make a sensor improvement, gets more difficult.
So you asked whether we had gaps to fill. I'm not going to talk about technology in this one, but on the operations. And I think there is a huge effort that has already been going on knowing what to do with what you already have. For example, there are a lot of exercises like Asterix in France, the French Space Command is conducted yearly. This exercise to train the forces to learn how to react and to operate in cases that are likely to happen if there is a more conflictual situation with the existing assets. And so that's a very important part to know how to react, and it also reveals what you would be lacking at this particular point. So it has two goals. First is to make a review of what you can actually do right now, and it also helps to as a prospective situation to know what you would do better in this kind of situations. So that's also something that we are doing with we are inviting foreign forces, US Air Force, for example, in order to foster cooperation and to learn how to use different assets in a global strategy.
So I'd say the two things that the West, if we were talking about that, needs to be concerned about as you look at China and Russia in space, for example. I'd say two things. One is you need to be able to go faster. You need to be able to innovate faster, deploy new capabilities faster, deploy integrated capabilities faster. That means leveraging commercial capabilities more than they are today, but securely. The second thing is space awareness, right? I mean, you talk about space as a warfighting domain. There are some capabilities, but the capabilities to know what's happening and be able to react to threats and command and control the forces in space and how they affect the terrestrial conflict. I think there's a long way to go to actually do that effectively in space.
Okay, just wait for them to stop. Okay. Okay, so my next question, what we've been hearing a lot in the media, is the risk of a nuclear detonation, nuclear weapons in space. How serious this is? And you also mentioned anti-satellite missiles. So are the concerns kind of serious? Is this something we should be really kind of be worried about? Anybody?
Thank you. Yeah, I've spoken a lot about Russian nuclear weapons in space in the last couple of weeks. So I think that's sort of two parts to that question, right? Number one, sort of what are we actually talking about here? We haven't got much further than we did in the initial couple of weeks in terms of what kind of weapon would we even be talking about. We know now that this would be a sort of in-orbit capability that would be able to sort of cause a nuclear detonation. As far as we're aware, that hasn't been launched yet, or at least the satellite in question isn't nuclear armed at the moment. It is a serious threat in the sense that nuclear detonations in space, as they are on Earth, are not a good idea by any stretch of the imagination. I mean, we're talking here about obviously the initial sort of electromagnetic pulse that would fry the electronics on board of satellites unless they are specifically hardened against EMPs. But we're also talking about a sort of environment of radiation that is left behind after the explosion, and that can last for a very long time. So even if satellites are sort of immediately affected, they would be affected for a long time thereafter. So it is a threat to be taken seriously. The question is sort of in what sort of scenario would Russia be making use of this? In my opinion, that would only ever be a sort of last resort, absolute last resort. Yes, Russia has very few allies left. Yes, Russia is not the space power that it used to be, but it would lose the last of its allies that it has left at this point. Again, we talked about China earlier. Obviously, the Russian-Chinese space partnership is alive and well. It certainly would not be after the placement of such an asset in space, and absolutely not after sort of using such an asset.
I think it's simpler than that. I think that there will be no nuclear weapons in space until the nuclear weapons that are currently under our oceans and deep in silos become more vulnerable than they would be in space. The equation is that simple. It's too expensive and too time-consuming and too difficult to conceal that kind of activity unless it's mandated by the fact that your boomers and your silos will become too vulnerable.
Anybody else? So my question, let's have a look at the commercial players. I mentioned at the beginning the role of Starlink in the war of Ukraine. We've also seen a use of a lot of commercial Earth observation imagery in that same conflict. So in your view, how will the role of commercial players grow in the defense sector, and where are the areas where they will play the greatest role?
Well, I guess as the commercial guy here, I'll talk first. So number one, I think commercial space has been critical to modern conflict for decades. And I think Juliana referenced the early 90s as sort of the first Gulf War, but you can probably even go back farther to see where it's played a role. But it certainly has proliferated extensively in recent times. And so specifically as it relates to communication, and I've hit on it, that you're seeing commercial communications capabilities in multiple orbits, many different new players, lots of interoperability coming between those networks. I mean, today there's not much, but I think in the future they're going to have to interoperate. And I think you're also going to see more connectivity between networks in space. So most of the network connectivity historically has been from space to ground, and it's been a two-way that way. Now you're seeing a lot more intersatellite links between, within networks, but in the future where you see optical communication advance even farther into space, I think you're going to see a lot more communication between networks and between layers through optical data relay. So you're going to have much more proliferated networks in space, and in the rise of software-defined networks, software-defined satellites that are much more flexible, multi-mission, and multi-orbit. So I think those are the things that I think are really going to see the growth of commercial, and it will be a much more. I mean, it continues to be a very important part, but I think it will become even more important. And I'm not we're not a remote sensing company, but I do have that background from my military days. I think the biggest advantage of commercial remote sensing is it allows governments and even the public to see what's happening without having to be declassify some highly sensitive national means. You can now getting not classified information that's putting out there on the internet or in the press as to what's happening. And we saw that in the build up to the Ukraine conflict. You're seeing what's happening in Ukraine, so you can actually have a lot of visibility. But it also means that as a military force, you need to be aware that you're not going to be able to hide very easily, because what you're doing is probably going to be known. I'll stop there.
So yes, I completely agree. Although Honora is the French aerospace lab, so it's more from the research side. But we have a research activity that's based on the support of the French Ministry of Defense and the expertise and know-how that has been built in the office. It was used for state-owned assets such as the French surveillance system GRAV. But we had a need to find a way to use this expertise and to provide it to the commercial sector. So there is a spin-off that has been created, which is called Asterium. And the goal of this spin-off was to use the know-how, the expertise, and to provide it to the commercial sector. Because in that frame, as a commercial entity, Asterium will be able to provide, as you said, a commercial service which is sometimes cheaper, faster, more effective. You do not suffer from the same procurement issues that can be rather lengthy. So it's a complement to the activity that's based on state-owned assets, which is dedicated to very specific tasks with a very detailed requirement and performance. And on the other side, all the know-how that you can use in the commercial sector, you can also use the commercial market to grow from it and to build a strong base that can then be used for defense applications using this commercial opportunity. So it's really complements the state-owned aspect.
Yeah, thank you. I mean, we talked a lot about Ukraine already as well, and sort of how often it's sort of called the first commercial space war. And I think it's important to keep in mind it's not the first time that commercial companies are involved in defense. So if we're looking back to the Iraq and Afghanistan operations, I think 90% of bandwidth at the time was provided by commercial providers, actually. So, this is not the first time this has happened, but we've definitely seen the rise of commercial companies in the last 20 years, the sort of new space era, the sort of increasing commercialization of the domain. And, specifically in the defense realm, we can definitely see a sort of huge amount of flexibility and agility that the inclusion of commercial actors lends to defense. There's the resilience aspect, sure, but there's also other areas where the innovation that commercial can sort of lend can really contribute.
Yeah, I'd like to take a different view on the same subject. The commercial operations around the world are much more vital to our future in space than we even realise, because the space domain, like every other domain of modern warfare, runs entirely on the veracity and fidelity of the intelligence. It's intelligence-driven. And if you look at the intelligence systems that inform space domain awareness, you will find that they've moved from being monolithic, in other words, single-structured, coherent data-gathering systems, to quite dispersed and diverse data sources today. So there are probably 5 or 6 significant companies contributing space domain awareness raw data and process data into what I call the space domain awareness infrastructure of today. And what we find looking at that compared to the veracity and usefulness of the monolithic intelligence structures we use let's say in the first 50 years of the space domain, they're far better because the companies have different ways of looking at the same problems, completely different orbital dynamics models and so on. And so the commercial entities are actually doing two things. They're creating a much more viable base truth in the data that we use for forming space intelligence conclusions. But secondly, they're allowing the more sophisticated organisations, which largely are national organisations, to float higher above what is a sea of raw common data to be much more sophisticated space operations in the intelligence domain. And it's, I said earlier, action in space now has much more severe implications and complications than ever before. So knowledge about the implications and the results of actions and making the correct action at the correct time is orders of magnitude more important than it ever was. So the emphasis comes back always on what we commonly call space domain awareness or space intelligence. And the commercial entities today, and I won't name them, produce easily half of the useful space domain awareness data today and make a huge contribution to securing space for us.
So going into the future, how do you expect the space domain to shape how defense operations are conducted, and how is it continue to become more, let's say, interconnected, and is it going to become more visible in this field?
I think quite simply put, it's another potential target for adversaries, right? I think as space becomes more and more integrated, as space more and more enables terrestrial sort of capabilities and operations, it's also increasingly sort of painting a target in that sense. So I think it's another sort of threat angle that we have to be aware of. I think the integration is only going to continue because the benefits that space brings us definitely sort of outnumber the downsides at the moment. So more and more data, more and more sensors, but also a lot more sort of room for disinformation, for example, through spoofing, a lot more sort of potential for destruction. So I always sort of try to sort of bring home the fact as well that we do also need to think about and train with, highlighting and train with terrestrial alternatives, and also for potential day without space, scaring us that scenario is.
So I think there is always going to be the fact that space keeps being used as a support for defense operations, but more and more we are going to see space being the warfare terrain in itself. And so it's already been started, mainly for collecting intelligence on other space assets. But threatening activities are already a reality in space, and I think they are going to be more and more usual. So that's going to be the future for them.
So I'd say that we've talked about the fact that space is very important to modern warfare, and I think Juliana hit on it a little bit, which is space is going to be increasingly in conflict, will be threatened, right? And so the systems, the networks you operate have to be able to be resilient, to be able to operate through the threat, be able to interoperate and be proliferated and be resilient. And then as you see human activity migrating into orbit, into higher orbits, potentially even to the moon, I think you're going to see what happens in space is going to evolve, much like it's, if you think about warfare, how it's evolved on the surface and under the surface in the air. It's much the same as human activities has developed in those domains. I think you'll see the same thing happen in space. And commercial space will be a critical part of it.
So before we go to the audience questions, I would like to ask each of you one hot technology that you think will play an important role in the future of defense operations, in your view.
Okay. Well, I think one hot technology that comes first to mind for me is the use of lasers in space. Lasers in space allow us, I referred earlier, to give us the ability to track with very limited assets 100,000 space objects with great accuracy on update frequency which matches the tactical requirements. It also gives us escalation dominance in many domains of space warfare, because with the lasers, we can tolerate massively intensified debris fields. So if you've got this technology, you can tolerate debris generation exercises, which in the past were formerly blackmail against space trainers. The other thing that's really special about the laser is that the sensor is also a weapon, and the same device which tracks could also mitigate threats at the same time. And that's a very useful capability. So we've just seen the beginning of the introductions of lasers in this role into the space domain, and I think they, applied properly, will enhance and extend our peaceful and profitable use of space.
Kind of stole my sound just then with the sort of optical links, etc. So I'm going to use something else. I think in orbit SSA is also going to be a huge game changer in the sense that obviously SSA, most of it is currently conducted.
SSA, that's space situational
Situational awareness, and most of it is typically conducted through radar stations on Earth, but being able to sort of add the space layer to that, potentially even optical, taking photographs in space of other assets, I think is also going to be change the game, specifically when it comes to threat detection, threat assessments, etc.
So that's satellites watching other satellites rather than telescopes on Earth watching satellites.
Yeah, exactly. It just enables us to sort of actually be able to sort of see what's happening in space. You can certainly no longer hide in space.
Yes, of course. I cannot say anything else because that's my area of expertise, so I completely agree. Space situational awareness is the main block, the first step to anything you need to do, because you need to assess what's going on, because you need that before taking action. And there is also, with all we've talked about, there are a lot of new activities that put the current technologies of space situational awareness to the limit of their performance and ability to actually identify and understand what's going on. For example, anytime you have a huge set of satellites being launched in the same launch, it takes quite a long time to actually process and understand which one is which. Or, for example, when you have satellites that are launched and then launch other satellites which launch again other satellites. All these techniques are pushing the capability to understand the situation to the limits, and that's the main focus if you want to be able to react.
So for me, it's software-defined networks on the ground and in space that will promote interoperability and flexibility and resiliency of those networks. And where you see that coming from is, for example, in space, you've got satellite payloads where you can put down maybe hundreds or thousands of beams and put them down dynamically, where in the past you had to put them through. Some military satellites have some beam shaping capability, but commercial satellites typically have not. So I think in the future you're going to see that be much more flexible so that you can adapt to threats if there's interference against a satellite, or adapt to the mission needs more readily than you can today. On the ground, you're also going to see software-defined networks in the sense that all the data centers that are full of proprietary hardware, most of that will be converted into software, so you can be using different waveforms just in a virtualized environment instead of having them a bunch of different line cards and modems. It becomes very expensive and very capital intensive and time consuming to replace. And the benefit of that is it does promote interoperability between networks, whether it's between various military networks, between commercial networks, or also between military and commercial networks, and then also between space and terrestrial networks as well.
Thank you. So now it's time for you. If you have a question, raise your hand and we'll get the microphone to you. Anybody has a question? No. So I'm going to ask another question. We spoke about the nuclear weapons in space. Are there other offensive technologies in space possible? Can we really think about a real war in space?
Yeah, absolutely. I mean, there's sort of several broad categories that we sort of distinguish. There's obviously the kinetic threat, which could either take the form of a missile started or launched from Earth to hit a satellite in orbit. We've seen those tests already happening, though it's not been used against an adversary satellite, so it's not been used in a war, for example. Kinetic could also just apply to a ground station, right? Sabotaging or sort of bombing of a ground station. And obviously kinetic sort of in-orbit activities as well. Again, we haven't seen that being used. That would be the sort of co-orbital or in-orbit sort of capabilities. The other is non-kinetic. We obviously already spoke about potential electromagnetic pulses in space. Another one is lasers, for example. But then we also have the electromagnetic sort of element and the cyber element as well. So, for example, jamming, spoofing, so the disruption of a signal, or even the replacement of a signal that would most likely be targeted at the sort of ground element. So think radios, ground stations, etc. And cyber. I think cyber is quite often the sort of forgotten counter space measure. And as we learned during the invasion of Ukraine in 2022, the company Viasat was targeted. Commercial actors are not exempt from these types of attacks. And I think cyber is definitely an element where we need to pay much closer attention to, because this has been possible for quite some time. There was also a big sort of attempt against a ground station, cyber attack against a ground station back in 2007 and 2008, to the point that whoever hacked into that ground station could have taken control of the satellites in question. They didn't end up doing that. But if we think about what was possible in 2007 and 2008, I think we do also need to worry about the cyber resilience in 2024, sorry.
Anybody else, anything to say on this?
I'd say Juliana hit the waterfront, covered the waterfront, so
Okay, I see a question over there. Can we get a microphone?
Thank you, Martin Hapter, Deal Defense. Since we are continuing talking about nuclear warfare or warfare in space, is this at all a realistic scenario to involve in prolonged space warfare, or is such a scenario not rapidly resulting in atrophied space capabilities and finally vanishing space capabilities within weeks or months or years due to collateral from increasing debris?
Yeah, so could you just repeat the question and put the microphone a little closer, because we didn't catch the whole thing. I'm sorry, just the sound is not very good in here on the stage.
Do you hear me?
Yes.
Question was, is a prolonged nuclear or any kind of conflict in space at all a realistic scenario? Or is it rather a scenario that would, within weeks or months, result in a vanishing of any space capabilities due to the collateral in line of increasing debris?
So who would like to take this question?
I think it's a good question. I mean, it obviously depends on the sort of size of the warhead, the orbit affected, at which angle. There's a whole lot of sort of orbital mechanics that become involved in sort of the question of how devastating would such a detonation be, how long would the radiation last, etc. That being said, I don't really see a scenario in which these become sort of routine sort of measures of warfare, if that was your question. It's certainly not a sustainable method. I hope that answers your question.
Anybody else? A question? Or,
we can make nuclear space warfare completely certain by saying right now it's impossible. It does seem rather unlikely, and that the reason is that assets in space are very easy to see. And therefore, you have to disguise them in various ways. But the protocols around protecting and managing and operating nuclear assets are fairly commonly known, and even in space, they would be relatively quickly discovered. And so it seems to be space is at this moment not a particularly safe environment for any country to deploy their nuclear assets.
Any other question? So this was nuclear weapons, but what about anti-satellite missiles? Is that a concern for, let's say, satellite operators, the adversaries developing anti-satellite capabilities? Could that become more of a thing of, satellites being shot down and so on?
I guess it comes down to, is it easier for an enemy or an adversary to take out assets, missiles in space, and is it worth putting them there, versus having, for the same cost, a much more massive and much more easy to conceal proliferation on the Earth's surface? And most of us would know intuitively what the answer to that is.
I think what we also must bear in mind is that these ASATs, specifically the sort of direct ascent anti-satellite missiles started from Earth, they're sort of bespoke and target one particular satellite. But actually what we're talking about now is, constellations, sometimes mega constellations of satellites. If we're trying to consider, for example, Russia's countermeasures against Starlink, and, the multitude of satellites that there are, it would not be possible to sort of take that out kinetically without effectively destroying the orbit and making it impossible to operate in that orbit. So from that point of view, kinetic ASATs against a mega constellation like Starlink, for example, is completely unfeasible.
Anybody has anything to say? So maybe, is there any question in the audience? So maybe my last question, how do we prevent war in space? Is there enough progress, you think, being made on maintaining a peaceful situation in space?
I have a 2,000-year-old answer for that. It's the Roman answer: if you want peace, prepare for war.
I'm unfortunately very pessimistic when it comes to sort of ongoing negotiations that are happening on the multilateral level. Specifically at the UN, we had the resolution on responsible behaviours, which I think, to be a bit optimistic, I think it did show that a lot of states are actually in favour of such a resolution. Obviously, there are actors that are against those resolutions that specifically prevented even from the conversation from really taking place. So I think in the current geopolitical climate, we're not going to see a sort of resolution on that. I think, space is not an apolitical environment. The sort of politics of the day, the strategies of the day are always projected into space. So I don't really see, at the moment, any room for negotiations. But I think I'm hopeful that the future will be a little bit brighter.
No, I would just say that being able to know what's going on is the first step to actually point out if there is any threat and to warn and start a dialogue in order to prevent escalating further. So I guess that's the first step to trying to avoid conflict.
Okay, thank you. Just Rory, last answer.
So maybe I would echo Ben that I think if history has proven anything about things around putting norms of behavior or policies about what's allowable in war or not allowable in war, those work as well as the people willing to abide by them until somebody decides it's to their advantage to use gas or use nuclear weapons or any number of things that have been we've tried to outlaw over the decades and hundreds of years. I think the same thing is going to happen in space. We can put all sorts of prohibitions around it and try to have international norms, but at the end of the day, you're going to be prepared that there will be conflict in space that will attempt to disrupt the infrastructure that's in space, and so you have to be prepared for that, to operate through it and be resilient.
Thank you very much. That's about as much time as we have. So thank you all for contributing to this discussion, and thank you all for being here with us, and hopefully see you at the next Eurosatory in 2026. Thank you.